Go, let's go. Sit down, all of you. Sit down. Okay. Okay, where did we stop in the last class? Scattering, it is not scattering. If we do numerical sum, so I think there are two numericals. Recovery clear. Okay. I want somebody to read the numerical names. Somebody from the guidelines. One of the everybody read for yourself. Go and read it in the class. What is given? Just check the data. Is data in my book and your book same? So you have to find C is equal to. Find so everybody understood the question. You have to find the speed and then guess what is the medium through which the wave is traveling. Find the speed. What is the relation between speed, frequency, and wavelength? V is equal to F lambda. What is mega? Mega is 10 to the power 6, which is 1 million, right? So 500 into 10 raised to 6. So this is 500 10 to the power 6 into 60 centimeter in meter is how much? 0.0 minus 2 meter, right? This is 60 minus 2. So this will give you meter per second, right? So 6 by 30. 1, 2, 3. So this is 3 into 10 to the power 8. So we are getting velocity of the wave as 3 into 10 to the power 8 meter per second. So what is the medium? Okay. So therefore medium is air or vacuum. Air or next question is wavelength of X-ray is only wavelength is given. You are asked to find frequency. So C is the ratio, right? Because it is an electromagnetic wave. So C is same for everything. So using so how much is this? 0.01 into 10 raised to minus 10 meter. 1 from this. How much is 1 from 10 raised to minus 10? We use that. This frequency. Everybody got it? Yes, 10 to 10 raised to power 20. Last part is scattering of light. Scattering of which light? Sunlight. Okay. Scattering of so light for us is sunlight. So once you understand sunlight nature, you can actually explain. You can apply it for all other lights. Are you done writing? ठीक है फिर से that was spectrum. It's not it is distorted. वीडियो दिखाया था प्रिज्म का स्पेक्ट्रम so scattering everybody knows scattering आपके चारों तरफ क्या है everybody साइलेंस मेंटेन करो देखो कितना अच्छा लग रहा है चिड़िया जैसे या मुर्गी जैसे stay silent you'll enjoy okay I know some of you come mostly to enjoy but बिलाल नहीं आएगा बिलाल नहीं इसके बाद अच्छी आवाज okay pay attention तो स्कैटरिंग क्या है तुम लोग बोल रहे हो मैंने बता दिया who will tell me what is scattering raise your hands what is scattering of light I have taught it in the last section how many of you can answer it I'm asking scattering you are asking dispersion both are different is scattering and dispersion same yes scattering is emission is scattering okay the rule is when I ask a question you raise your hand you start answering right away. Okay, so some discipline. So you just raise your hand. Is scattering and dispersion same? No. Who wants to answer? Where answer there? Yeah, no. You have to raise your hand when I ask the question. Okay. So who wants to answer? Is it same or is it different? Who wants to answer? Who wants to answer? Okay, you answer. Stand up. So what was the question? Is dispersion and scattering same? No. They are appearing in two different units, therefore they have to be different. So dispersion, you understand? What is dispersion? इधर देखना मेरे से बात कर इधर डिस्पर्जन क्या था इधर देख यार करने की जरूरत नहीं dispersion क्या था whenever we pass a white light through a prism तो वो split हो जाता है split होता है 7 colors में that splitting of white light in 7 different colors is dispersion scattering क्या बताया था मैंने scattering अब साथ में बात आंसर करो
Particles absorb light energy and then disperse it in different directions.
Okay. Why are you using disperse? Re-emit in random direction. That's absorption of light. Okay. And then re-emission. But when the light is re-emitted, in what direction it will be re-emitted? We don't know. Random direction. So it goes in all directions. But that thing happens according to a rule. What is the rule? There are two things. One is size of the obstacle, size of particle. Okay. So, what is the rule of scattering? Scattering of light is inversely proportional to fourth power of lambda. Okay. And now you have to also understand which object can reflect a light. The object has to be comparable to the size of the light wave. How do you quantify the light wave size? By its wavelength. The size of the light is size of the particle. To be able to scatter it must be comparable to the wavelength. If it is smaller, then that light will pass through it. जैसे कि अगर ये ऐसा बड़ा सा wave जा रहा है, then this particle will not be able to reflect it back. That wave will pass through it. But if the particle is this much and the wavelength is like this, if it is smaller, then it will be reflected maybe in this direction. Or if it hits here, so maybe it will gone in this direction. You understand? So two things are important. One is scattering is inversely proportional to fourth power of lambda. That means when the scattering will be more, when the wavelength is bigger. Okay? Am I right? You have to correct me, right? So when the wavelength is smaller, bigger may answer will be, if the wavelength is big, it is 4 power. Or come scattering ho jayegi. So if the wavelength is bigger, then the scattering will be less. If the wavelength is less, scattering will be more. Which is the least wavelength in the spectrum of light? Don't answer everybody. Which is the least wavelength? हाँ बताओ. Violet color. ठीक है. So जो spectrum है Vibgyor. ठीक है. So this side is called blue part of the spectrum. All violet, indigo, blue, everything is called blue. This side is called red. Okay? So scattering is more for smaller wavelengths because this side the wavelength is less. This side the wavelength is max. Okay? So maximum scattering will take place of blue side of the spectrum. Acha. By what kind of particle? Obviously the wavelength is small and only small size particle can scatter blue light. Okay? So the upper layer of the atmosphere consists of air molecules. So these are the smallest particles. So when the sunlight enters the atmosphere, first it encounters all the air molecules. So maximum scattering takes place of blue color. Okay? So that's why you see the sky as blue. Right? When you are not looking in towards the direction of sun, elsewhere, then only. If you look towards the direction of sun, then you will see white. Okay? And why it is so, that's what is the topic of this. So here I have explained what is scattering. Now we understand different phenomena. Now that is interesting. What is the first phenomena? So today we are discussing applications of scattering, having understood how the scattering takes place. ठीक है तो देखो तो देखो रेड कलर ऑफ सन एंड सनराइज So first application is red color of sunrise. देखो क्या होता है इसमें at sunrise and sunset, let us say this is and this is the atmosphere. Okay. So when the sun has risen in the morning, ये diagram भी पता है ना? देखो क्या होता है? Sun का position देखो एक morning में. Let's say you are observer over there. Right? And this is the position of sun at noon. So this will be evening, right? देखो morning और evening में how much distance the light travels? This much. During morning and evening, sunlight travels maximum through the atmosphere. Okay, and at noon time it travels only this much. So when sun is at noon time, it is directly above your head. It travels very little, very short distance through the atmosphere. So where will scattering take place more? Where is chance of scattering more? Here, and it will meet variety of particles. Correct? So first all the blue color light will be scattered. Okay? So in the spectrum, in the Vibgyor, so when blue is scattered, so what are you left with? Red. जैसे जैसे you come closer to the Earth's horizon, you get particles of bigger size. So bigger size particle will reflect colors of bigger wavelength. Blue खत्म हो गया, उसके बाद क्या बच रहा है? ये ऐसे green, yellow, वो सब खत्म. तो last में white minus blue gives you red. ठीक है, इसको मेजरली 7 कलर है, बट इसको मेजरली ब्लू और रेड बोलते हैं. So when blue is gone, what is remaining is red. So observer sees only red color in the morning and sunset, because maximum scattering takes place. But at noon time, there is not enough chance for scattering. So all the colors almost reach the observer without scattering. So it appears as white only. So even during morning as well as noon, elsewhere it will be seen as blue also. Understood? Even in morning, it's not that the whole sky is red. No, it's only around sun it will be red. Elsewhere it will be bluish. Got it? So this is what it is. Next application is why is the white color of sky at noon? That is also explained. White color of sky at noon. Okay, these two things are explained. Then blue color of sky, that is also explained. Blue is the maximum scattered color, so it is put. Okay, so that is also explained. Blue color of sky. Now this diagram explains all three applications, and this is the diagram from NCERT. और ICSE में थोड़ा ऐसे नहीं explain किया है, paragraphs में explain किया, but this diagram tells you clearly where is the distance traveled more and less. Okay. So three applications are to black color of sky in absence of atmosphere. Obviously, particles are in atmosphere. So when there is no atmosphere, no scattering. When there is no scattering, will you see blue color when you are standing on moon? No. Moon पे जाएंगे तो moon has no atmosphere. So there is no scattering of light. मतलब moon पे खड़े होके ऊपर blue sky नहीं दिखे. ऐसा रात को हमको कैसे दिखता है? Dark clouds has been What I'm trying to say is, when you're on Earth, that too, night में क्या दिखता है तुम्हें sky? Dark दिखता है. क्यों? क्योंकि sunlight नहीं आ रही इसलिए. ठीक है? तो scattering नहीं होगा. अच्छा. मून पे तुम जा रहे हो तो तुम्हें वैसे भी उसकी स्काई ब्लू नहीं दिखेगी. मून पे दिन में भी तुम्हें डार्क ही दिखने वाला. ठीक है? सन की तरफ देखोगे तो व्हाइट दिखेगा वो, क्योंकि क्लोजेस्ट है. और अर्थ देखोगे मून से तो अर्थ कैसे दिखाई देगी? ब्लू, क्योंकि अर्थ में ब्लू ह्यू पूरा एटमॉस्फेयर में स्कैटर्ड है, तो अर्थ तुम्हें ब्लू कलर की दिखाई देगी मून से. ठीक है? ये सारा स्कैटर्ड. सो ब्लैक कलर ऑफ स्काई इन एब्सेंस ऑफ एटमॉस्फेयर. व्हाइट कलर ऑफ क्लाउड्स. अब क्लाउड्स क्यों व्हाइट दिखाई देते हैं? देखो, क्लाउड का जो क्लाउड कंसिस्ट ऑफ aggregates of water molecules. Water molecules नहीं, aggregates of water molecules. Drops. So that size is too big. So it will now scatter all, it will reflect all the wavelengths together. When all the wavelengths are reflected together, it will be white light. That's why cloud is appears white. If it is so thick a cloud consisting of smoke, etc., it will not let sunlight reach you. Then you see dark clouds. So absence of light is dark cloud. Okay. White is partially RI reflected. So you'll see white. Okay. Now, so use of red. So why do we use red light for danger signal?
Scattering least.
Least scattering है. So it can be seen from the farthest distance. Atmosphere में चलेगा तो भी उतना scatter नहीं होगा. All other color may get scattered. All right. So I think we have no numericals in this chapter. We'll start with sound. Is it started in your school? Oh. So this was a very small chapter, but conceptually pretty high. Okay?
Yes.
और ये तुम्हें higher class में और अच्छे से समझा. Okay, for students, right? How many science prospects? Most of you are taking science. Take it. Lawyers, policemen, lawyers. IAS technicians, tested for UPSC. Any district collector? IAS ideas So I think this last Sunday there was a career counseling, right? Nobody attended it. What did they tell you? It's very important for you to understand yourself. The biggest thing is, biggest problem in the world is we understand everybody else, but not ourselves. We don't know what our strength and weakness is. Right? So if you have that clarity early in life, then the chances of failing in life will greatly reduce. So थोड़ा अपने पे काम करो. You figure out what package you are. Meaning, what interests you most. If you get to do thing of your interest, you can do it 24 hours without getting tired. तो उसके सोचो थोड़ा और सोचा करो. खेल के बारे में There is pretty clear about what you want to break songs. The multi-grade, not okay. Okay, let us start. Okay, I think all of you have learned about all of you learned about sound. It is a form of energy. What does it do? Vibration produces sound, and then sound can also produce vibration in your ear. Okay, so you're right. So it's energy transfer. Energy transformation. How it is produced? Sound is produced by what is vibrating right now? So everybody knows this. Okay. What kind of, so how does sound travel? Raise your hand. Okay, that thing. When I'm speaking, you know, nod. Okay, don't say yes sir, no sir. You nod. Okay. So when I'm speaking, everybody is able to hear me. Yes, sir. Yes, no. Yes. No. What is this? Okay. This sector is only in Mumbai. Go to any part of the country. हाँ खाना खाएगा अगर तुम नॉर्थ में जाओगे या साउथ में जाओगे तो तुम्हें क्लियरली हाँ बट यहाँ पे ऐसा ऐसा क्या समझे Okay, the question is, when I say I'm speaking, everybody is listening to me, right? How does the sound reaches you? The form of waves. The form of waves. Sound propagates in the form of waves. Now, what is a wave? Wave is not a medium. Wave travels in the medium or maybe without a medium. What is wave? Compression. Wave is the mode of transport of energy. ठीक है तो वेव से तुम क्या करते हो वेव कैरीज योर सिग्नल मोबाइल से जब तुम बात कर रहे हो तो थाउजेंड्स ऑफ किलोमीटर अवे यू आर एबल टू स्पीक ठीक है लेकिन जो तुम बात कर रहे हो वही दूसरा बंदा सुन रहा है तो हवे में जा रहा है तुम्हारा कम्युनिकेशन कैसे So there is carrier wave and there is a signal wave. तो तुम टेलीकम्युनिकेशन इंजीनियरिंग भी करेगा तो वो सीख जाएगा या 12th में पहले ये चैप्टर होता था अभी नहीं So wave carries signals. तुम्हारे रेडियो में गाने आते हैं ना गाने रेडियो में आते हैं तो उसका स्पीकर जब वाइब्रेट होता है तो तुम्हारा कान वाइब्रेट होता है ऐसे तुम सुनते हो लेकिन ब्रॉडकास्टिंग स्टेशन में और तुम्हारे स्पीकर के बीच में क्या आता है waves. So wave is carrying that information. ठीक है लेकिन तुम्हारे पास बहुत सारी इंफॉर्मेशन आ रही है फिर तुम ट्यून करते हो पर्टिकुलर स्टेशन तो वही चीज तुमको सुनाई देती है यानी वेव में पूरा मिक्सचर है एक्सीडेंट नहीं होता सब प्रेस क्रॉस करके जा रहा है बेसिकली देयर आर इलेक्ट्रॉनिक सर्किट्स टू एक्चुअली फिल्टर द रिक्वायर्ड इन्फॉर्मेशन ठीक है, तो अभी तुम ये समझ लो वेव इज अ मोड ऑफ ट्रांसपोर्ट ऑफ एनर्जी, वो एनर्जी इन द फॉर्म ऑफ सिग्नल्स ट्रेवल कर, पूरा इंजीनियरिंग वो सिग्नल को बनाने में, मिक्स करने में और दूसरे साइड में सेपरेट करने में जाता है, ठीक है। तो ये है, और इसी से हम चंद्रयान से कम्युनिकेट कर रहे हैं। और चंद्रयान वी आर एबल टू कंट्रोल सिटिंग हियर, हमारा लेवल चंद्रयान का नहीं, मैं तुम्हारे लेवल की बात कर रहा हूं। Can you control your TV sitting on your sofa? How do you control it? Remote. TV control हो जाता है। Remote से आगे जा रहा हूँ। ठीक है? तो यही चीज miles, मतलब lakhs of kilometer हमें भी तुम कर सकते, ठीक है? वो वेव से होता है, वेव। इसलिए आगे का फिजिक्स में वेव इज वेरी इंपॉर्टेंट, 11th 12th में बहुत कुछ आएगा इसको। तो टाइप्स ऑफ वेव्स, कितने टाइप के वेव्स होते हैं और साउंड you have mechanical,
elastic or mechanical
and electromagnetic. और एक है मैटर वेव्स जो तुम्हें पता नहीं है।
अच्छा मैकेनिकल, ओके,
ठीक है। इसमें से सिर्फ तुमको ये दोनों के बारे में है, ये नॉट इन स्कोप।
सर मैकेनिकल वेव्स को इलास्टिक वेव्स बोलते हैं।
इलास्टिसिटी एक प्रॉपर्टी होती है मीडियम, तो वेव उसमें प्रोपेगेट करता है, ठीक है। ठीक है, मैकेनिकल में क्या होता है, लॉन्जिट्यूडिनल एंड ट्रांसवर्स, दो टाइप के वेव होते हैं। देखो वेव कितने टाइप के हैं, मैकेनिकल, इलेक्ट्रोमैग्नेटिक एंड मैटर वेव्स, ठीक है। इलेक्ट्रोमैग्नेटिक एक अलग कैटेगरी की वेव है, मैटर वेव इज आल्सो डिफरेंट कैटेगरी, वो तुमको अभी है ही, ठीक है। मैटर वेव जादू है, जो लाइट को तुम क्या बोलोगे, पार्टिकल है कि वेव है। पूरा जो यूनिवर्स है, सुनो, यूनिवर्स इज मेड ऑफ ओनली टू थिंग्स, क्या, रेडिएशन एंड मैटर। पूरा यूनिवर्स किससे बना है, रेडिएशन एंड मैटर से। आइंस्टीन ने क्या बोला था, मैटर रेडिएशन में कन्वर्ट हो सकता है और रेडिएशन से मैटर बन सकता है। देखो E is equal to mc square, मतलब क्या, your thought when it is at thought level it is energy, but if you manifest something out of that thought, something tangible, then thought becomes energy. We're talking philosophy right now, but it is not philosophy anymore. This equation connects, मतलब you can create something out of nothing, and there is something, like when we are a living form, we are something.
Yes.
What when we are dead? We are radiation. Atma never dies. Then that Atma finds another body. So this E is equal to mc square is a technical representation of what we have been saying for so long. Understand?
Yes, sir.
So in this body, a million, billions, God knows, no timeline for it. You're very old actually. Maybe you're so older than me. Look younger, right? That's why ये होता है ना कि इतना छोटा सा बच्चा है, उसको सब कुछ आता है. How do you explain that? हाँ, so isn't it interesting? Okay. So this is too high for you. So for me, everybody, right? It's a different thing. But now you understand this, right? Thoughts becomes things. ऐसा philosophy में पढ़ा होगा तुमने, है ना? Novel पढ़ते हो. ये रियलिटी में पॉसिबल है, ठीक है? ये समझने के लिए it will be helpful to know all this. So then you will be able to differentiate. Yeah. What is longitudinal wave? These are the type of waves which require medium needed for propagation. Sorry, ये यहाँ पे आएगा medium needed. Mechanical wave propagates only in a medium. It cannot propagate in vacuum. Okay? Mechanical wave need medium to travel. Mechanical waves. और mechanical में दो type के waves होते हैं, longitudinal and transverse. तो longitudinal का example है sound wave. और transverse का example है waves in strings of guitar, है ना? So ये क्या है? Waves produced in ये just एक example है, बहुत सारे possibilities हैं. In strings, guide and both ends. For example, like और सितार बोलते सितार तो बोलना पड़ेगा सितार ओके तो ठीक है तो अब इसमें क्या डिफरेंस है एंड देन वी से इलेक्ट्रोमैग्नेटिक वेव कौन सा है लाइट वेव है ना लाइट medium not required for this case medium not required electromagnetic ठीक है लाइट वेव के लिए मीडियम की रिक्वायरमेंट नहीं है और वो इलेक्ट्रोमैग्नेटिक वेव है लेकिन ये वाला ये भी ट्रांसवर्स है वो भी ट्रांसवर्स है तो ध्यान दो ये दोनों ट्रांसवर्स वेव में फर्क है एक ट्रांसवर्स वेव मीडियम में चलता है और दूसरा बगैर मीडियम के भी चल सकता है और मीडियम में भी चल सकता है लेकिन ट्रांसपेरेंट मीडियम होना चाहिए ठीक है तो ये बहुत सारा अगर तुम ये समझ गए तो फिर बाकी वेव्स समझने में दिक्कत नहीं मैटर वेव्स बहुत बड़ा जाता है मैटर वेव्स क्या है देखो अभी हम तुम्हें बता रहे हैं कि लाइट क्या है लाइट इज रेडिएशन यानी वेव एनर्जी बाद में तुम्हें पता चलेगा कि लाइट इज आल्सो अ पार्टिकल it's called it has got dual nature duality of light तो वो duality तो सब में है we are male and female at the same time Can a girl be born without a father? Can a girl be born without a father? Can a boy born without a mother? Doesn't have identity capability, but he has a father or mother, right? So that is why they are revered in this culture because they are very close to home. You understand what the purpose of life? What's the purpose of living life? What does it mean? What does it mean? What does it mean? Your last birth. That's what. Again, it is not. That's what it means. Everybody tries for that. So, if you are not a good tender, if you are quite far away from Did you get the answer? Okay, coming back to waves. So when you have a broadened viewpoint, then only you can understand all this. Because now education is going to be very interesting. Isn't it? What did I say? What is transfer wave? Transfer wave are getting mathematics. How do we categorize between transverse and longitudinal? Okay, gender. Everybody is a third gender. What is the difference between longitudinal and transverse? Pay attention. This is the direction of propagation of wave. Okay. I think he got hooked on to that topic. Look here. This is the direction of propagation of wave. Direction of which wave is traveling. Okay. So if it is a longitudinal wave, what it will do? I said wave is a mode of transport of energy. What energy are familiar with? Kinetic and wave is moving. Motion में what are the energies? Kinetic and potential. If wave is having energy, so when it is traveling through the medium, it will disturb the particles of the medium. So disturb means it will collide. So it will transfer energy. So those particles of the medium, if it vibrates in the direction of propagation of wave, and such wave we call longitudinal. Okay, like when sound is traveling, you are able to listen to me. So all the air molecules, they are vibrating. My information is traveling like this. So these particles of the medium, they are vibrating at their position. Air near me remains near me. Okay, it only disturbs the next. Then the next, then the next. It's like if you have a train, right? Train, the engine is in the front, right? When the engine pulls the first bogie, the last bogie is connected. That also gets pulled after a few seconds, after fraction of seconds, right? So that is the transfer of energy. Like if you're standing in a queue, let's say 10-20 students, the last person, domino effect. Okay, the last person pushes only the boy or girl in front of him, and then his disturbance reaches the last one. That's the propagation of wave. You understood what is wave? Wave is only propagation of energy, not the particles who are carrying that energy. You understand? Very deep understanding. It only carries the effect or the energy, not the particle which is. So it's like letter passing. I want to pass the attendance sheet. Attendance sheet reaches without you leaving your position. You understand? So none of the particles leaves its position. It only vibrates at its position. This is how wave propagation takes place. Particles of the medium do not leave their position. It only oscillates. जैसे तुम passing के time पे इधर-उधर oscillate करते हो, ठीक है? वैसे होता है. Now, अब यहाँ पे क्या होता है transverse में? Transverse में, when the wave is moving in this direction, The particles vibrate in upward, perpendicular to the wave direction, like this. What is the motion of the particle of the medium? Like this. Like on a water wave, you drop a stone. If still water, a stone drop karo. Ripple effect आएगा. It spreads. So what happens? Is the water traveling? No. Is the water traveling? घर में glass इतना बड़ा ले लो, tub ले लो, tub होता है bathroom में, भर लो उसको. Drop something. You'll see the ripple going like this. Is the water traveling? No. Water is dancing up and down. Then once it goes up and down, then the elasticity transfer the energy to the next water, Okay, so like that. So if there is a rope, you do this. You are giving a jerk up and down to the rope, but you see the ripple going to that. Huh? Yes, वो जो तुम exercise कर रहे हो, you are giving this up and down motion, but you feel that rope is traveling. Is the rope traveling? And what is traveling? Energy. Kinetic and potential energy. Because all the medium, what is the medium? The rope itself. And the rope particles are going up and down. So their kinetic and potential energy is converting all the time. The more flexible the rope is, more fast, swift waves you will see. So it all depends on the medium property, how the wave will travel. So the more elastic and less dense the medium is, more wave will propagate through. So far I have taught you about wave, right? Now come back to sound wave comparison with light wave. Should I erase it?
Yes.
Yes. Yes.
Did you like this kind of lecture?
Yes.
Because you are story, right? What is the Okay, now I'll just give a short comparison between these two waves. So first, what is sound wave? What is its speed? Let's begin with speed. At what temperature? This is ordinary room temperature. This is room temperature. This is 0 degrees. NTP. NTP. This is that. What about this? What about speed of sound? Light. ठीक है और क्या है ठीक है now you understand it requires medium. These two waves you encounter daily basis, so you need to know what is what. Okay, these are different types of waves. Medium not required. This is mechanical. Very good. Mechanical longitudinal. Very good. Good. So mechanical longitudinal. You just know longitudinal. Only mechanical is longitudinal. So that is also okay. This is transverse. So what is transverse in this case? Electric and magnetic field. Okay, and here, so therefore, the electric and magnetic field is associated with the light wave. So that is not particle of the medium. These are its own component. They manifest each other. Okay, you'll take some more like higher classes to understand that. But okay, as of now, this is fine. So this is transverse. Then what about electromagnetic reflection? Will they obey? This is wave. So they will both follow reflection and refraction. But there is a difference. Light wave, what is the wavelength?
Sir, light 10 to the power minus.
Very small, 10 raised to minus 10 meter. Very small. So even small object can reflect light. A piece of a very small mirror can also reflect light. Sound cannot be reflected by small objects. Okay, so the difference is wavelength. What is the wavelength of sound?
10 to the power minus.
Wavelength of sound wave is
10 meter.
10 raised to minus 2 to 10 meter. This is the wavelength of sound wave. So you should remember this. Wavelength of light wave is order of 10 raised to minus
6 meters. Minus 6.
6 meters. Why do we say so? Because if you have 8,000 angstrom, देखो सबसे बड़ा वाला ले 8,000 angstrom. So 8,000 को तुम approximate करो ये 10,000 हो गया. ठीक है? Imagine it is 10,000. An angstrom is 10 raised to minus 10 meter. So this gives you 10 raised to minus 10. ठीक है? सबसे बड़ा वाला जो red color है तो उसको approximate हमने कर लिया because it is never frozen at 8,000. It can spread beyond also. Okay? बढ़ता रहेगा नहीं फिर तो वो invisible हो जाएगा इंफ्रारेड में चला गया. बाउंड्री जो है ना रेड कलर की वो बैंड है. It is not just 8,000. तो आगे पीछे हो सकता है. वैसे ही 4,000 नहीं है 3,000 भी हो सकता है 4,000 भी हो सकता है थोड़ा 4,000 से ज्यादा भी हो सकता है थोड़ा बैंड है उसमें. ठीक है. So therefore, इसके लिए बड़ा reflector चाहिए. So requires in this sound chapter we are going to learn about reflection of sound. That's why this data is very important. Sound can only be reflected by bigger obstacles like wall. Yeah? So reflected by obstacles. मैंने क्या बताया था रिफ्लेक्ट करने के लिए ऑब्जेक्ट का साइज कंपेरेबल टू वेवलेंथ होना चाहिए ना. सो वेवलेंथ बड़ा है लाइट का तो इसके लिए इसको रिफ्लेक्टेड बाय बिगर ऑब्जेक्ट. such as walls, hills, forest edge. ठीक है ना. तो या प्लाईबोर्ड मतलब प्लाईबोर्ड होना चाहिए बड़ा. Whereas this can be reflected by as small obstacle as a air molecule. उससे भी स्कैटर हो जाता है ये. ठीक है. So can be scattered, can be reflected by every lecture I have to find a story to give out. बहुत प्रिपेयर्ड हो तो एक स्टोरी ढूंढना पड़ेगा थोड़ा. नए एलिमेंट्स को करने Okay, so next class में we will cover reflection of sound. Velocity of sound क्या है? इलास्टिसिटी और डेंसिटी होता है ना, डेंसिटी ज्यादा होगा तो स्पीड कम हो जाएगा। और मुझे तुमने बोला वो भी सही